So, good morning, everyone, and welcome to this lecture. This is lecture number 8, and we are dealing with series parallel combination. In the last class, series parallel combination of resistance, I must add. In the last class, we had seen the series combination, and we had seen how power is divided, power in a DC circuit or power through a resistor is I square into R. It is in the direct ratio of resistance. In series, current is same, so the resistor which has more resistance will have more power. We had also seen the formula of division of voltage. In a series combination, voltage divides in direct ratio of resistances. Do we remember this, everyone? Yes or no?
Yes,
Remember
sir.
what we have done? Okay, in today's class, to start off today's class, since we have done with the series combination, we will go ahead with the next one. And what is the next one? The next one is parallel combination of resistors. Parallel combination of resistors is the next heading. And what is parallel combination? Now the resistors would be arranged in such a way that resistors would be arranged in such a way that the voltage across them would be same, but the current going through them would be different. Do we understand this? Voltages would be same, but the current going through each resistor would be different. This type of combination would be known as the parallel combination. As you can see over here, all the resistors have the same voltage drop V. Do we see this? But you can see the currents. In the resistor R1, the current is I1. In the resistor R2, the current is I2. And in the resistor R3, current is I3. The total current though is I. Do we see this? So in this combination, what you have to remember, point number 1, voltage drop across each resistor is same, as you can see, but current across each resistor is different. Total current, if I say total current I, total current I will be equal to I1 plus I2 plus I3. Do we understand this? Yes or no?
Yes, sir.
Now this I1 will be equal to V by R1. I2 will be equal to V by R2. And I3 will be equal to V by R3. And this total current can be written as V by R equivalent. Do we understand this? V by R equivalent, where R equivalent will be the equivalent resistance. So what I can do is I can replace this 3 resistors by one single resistor. I can replace this 3 resistor by one single resistor. The voltage would be V, the current would be I, and the resistance will be R equivalent. Can anyone tell me how much will be this R equivalent? 1 by R
1 by
equivalent
R1 plus
equal
1
to
by R2 plus 1 by R3.
1 by R1 plus 1 by R2 plus 1 by R3. That is what you need to remember in this series, in this parallel combination. Voltage is same, but current across each resistor is different. Do we understand this?
Yes, sir.
Okay, I'll give you 1 minute to note these things down. Once you are done, please let me know. Since you have completed this, let me give you a question based on this, and then we will move ahead. So let me make a question and I will ask you to solve it. I will ask all the things that are possible to ask in this question. So with one question, we will be dealing with all the questions that are possible. These are three registers which are connected in parallel, as you can see, across a battery which is 12 volt. This is 2 ohm, this is 4 ohm, and this is 6 ohm. So you have to find out the current in each resistance, the total current also. If you add up all these resistance, all this current, you will get the total current, the voltage drop across each resistance, and the power consumed in each resistance. Also, you have to tell me the total power consumed by this. You should also tell me what is the equivalent resistance of this system. So I'll give you 2 minutes to give me the answer of all the questions that are possible here. Once we understand this, we will be able to move ahead. I'll give you 2 minutes to do this. Let me know once you are done. Okay, so how are we going to do this? We can see that the battery is 12 volt, and the resistance here is 2 ohms. Voltage is 12 volt, resistance is 12 ohms. So I can find out the value of I1, the current which flows in this branch. What will be the value of I1?
6 amperes.
I1, the green current, I1 will be 12 divided by 2, which is 6 amps. Now, you look at the second register. Second register is 4 ohm. Let me call that current as I2. What will be the value of I2? 12 divided by 4, that is 3
3.
amps. Moving down on the third register, this is 6 ohm resistance. Let me call the current as I3. What is the value of I3? 2 amps. 12 divided by 2. Now, if I talk about the total current I, what will be the total current I?
11.
Total current I would be 11 amps. What is the voltage across each resistor? The voltage across each resistor is 12 volt.
12.
Okay. Now let me find the power dissipated in each resistor. What will be the power P1 in the first register? We can write it as P square by R1. That is the simplest formula because V is same. You can also find it as I square into R. Doesn't matter. You can do it in any ways. V square by R I am using. So how much is that? V square is 12 square. 12 square is 144 divided by 2. So that will be 72
72.
watt. Moving on to the power in the second register. Power in the second register P2. I can again write it as V square by R2. I am writing it as V square because V is same in all. That is the only reason. So it will be 144 divided by 4, and the answer will be 36 watt. As you can see, they are coming in the same ratio. Talking about the power in the third register, P3 will be again V square divided by R3. V square is 144. This divided by 6.
24.
24 watt. Now I can ask you what is the total power in the three registers. Total power P. How much? I think it is 132.
132. Sir.
132 watt. Now you can find out the equivalent resistance. How will you find out the equivalent resistance?
Sir, 11 by 12.
1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. When you solve this, you will get the value of R equivalent, and value of R equivalent will come as 12 by 11 ohm. The value of R equivalent will come as 12 by 11 ohm. So you can replace these three registers and just put one register. You can replace these three registers and just put one register for them, and you can very easily see this is 12 volt. The current you have already found. From here also you can find the R equivalent. R equivalent will be 12 divided by the total current. So in any ways you do, you will end up with the same result. Do we understand this? Do we understand this, everyone?
Yes, sir.
Okay. Everyone has noted this down?
Yes, sir.
So then we move ahead and we write this small heading, division of current. Division of current in parallel branch. If you have two parallel branch, how does current divide? So let me have these two branches. As you can see, these are two parallel branches, and let us say the total current that is coming in these two branches is I. This resistance is R1 and this resistance is R2. The current that goes in this branch is I1. The current that goes in this branch is I2. They go like this and then they again become I. Do we understand this?
Yes, sir.
Now, you must understand simple things, that if you take these 2 points, point A and point A and point B, the potential difference between A and B, whether you go in the upper branch or you go in the lower branch, the potential difference would be same. Potential difference does not depend on the path. So from this you can write I1 into R1 will be equal to I2 into R2. Do we understand this?
Yes, sir.
Also you can write the total current I will be equal to I1 plus I2. Now if you put both these conditions together, you will get the value of I1 and I2 in terms of I. And what will you get? You will get I1 will be equal to I into R2 divided by R1 plus R2. I call this as division in the inverse ratio. I call it as division in the inverse ratio. Why inverse ratio? Because with I2 R1 is coming and with I1 R2 is coming, we say that current divides in inverse ratio. The resistance, the resistor which has more resistance will get less current. The resistor which has less resistance will get more current. The resistor which has more resistance will get less current. Do we understand this? This is what we call division of current. Is always in the inverse ratio of resistors. Division of current is always in the inverse ratio of current. The branch which has less resistance will get more current. The branch which has more resistance will get less current. Do we understand this?
Yes, sir.
Current divides in inverse ratio of resistance. The branch which has more resistance will get less current. The branch which has less resistance will get more current. Have you noted this down, everyone?
Yes, sir.
Boys, have you noted this down? Not getting any response. Abhiram has noted. What about the boys in the class? Have you noted it down? Have you noted it down, beta? Okay, I will take this as a yes and move on. And I bring this question for you, question number 2. A 6 amp current is going into this branch. This resistance is 2 ohm. This resistance is 4 ohm. If I call this current as I1 and if I call this current as I2, can you tell me what is the value of I1 and I2? You are not able to see this right now. You will be able to see it. I have drawn a circuit, small part of a circuit. 6 amperes is the total current. I1 goes in the first branch, I2 goes in the second branch. I'll give you 2 minutes to give me the value of I1 and I2. So, as you can see, this is the diagram and you can straight away put the value. If I call this current as the blue current, I1, how will I find the value of this blue current? I1, the current in this branch. Total current is 6 multiplied by inverse ratio. So you have to multiply it by the other resistor. Other resistor is 4 divided by 2 plus 4. And you get the answer as 4 ampere. I1 becomes 4 ampere. If I look at this pink one, I2, the resistance is 2 ampere. Resistance is 4 ampere. You get the value of this I2. Total current is 6 multiplied by the inverse, the other resistor, 2 divided by 2 plus 4. And as said, that the branch which has more resistance, 4 ohms, get less current, 2 amperes. The branch which has less resistance, 2 ohms, get more current, 4 ampere. Do we understand this?
Yes, sir.
So current divides in inverse ratio of resistances. We understand this? Yes or no?
Yes, sir.
Okay. Now let me give you one more on this. Now I have the same scenario, but now I have done something differently. This is 6 amperes current. This is 2 ohms, and in the lower half you can see there is no resistance. We call this as shorting. This circuit has been shorted. The resistance of this ohm, there is no resistance. The resistance is 0 ohm. There is no resistance here. The circuit has been shorted. Now what happens if the circuit is shorted? What happens if the circuit is shorted or you connect it like this? What will be the current in this branch if I call it as I1? And what will be the current in this branch if I call it as I2? This is known as shorting of the circuit. I'll give you 2 minutes to give me the answer. Well, that is exactly correct. I1, this current, the blue current, this actually becomes 0. No current will flow through this branch because the other resistance is 0. The entire current will come from here and will go through this branch. So the 6 ampere current will keep on flowing like this. Do we understand this? 6 amp current will just flow through the lower branch. This is what I call shorting of shorting of a circuit So whenever a circuit gets shorted, and that is why it is very dangerous, whenever this fault occurs, this shorting occurs, a large amount of current can flow through a branch, and therefore we have fuse wires put in your line. You can call them circuit breakers, MCBs, you call them. Whenever some fault happens, this MCB breaks off the circuit so that not large current flows through it. Do we understand this? Yes or no?
Yes, sir.
Now, since we have seen the division of current, let us just go back a bit and we also see the division of charges on a capacitor. We would have done this before, but since we are doing it systematically here, let me just put in that one as well. Now, division of charges means you will have two capacitors put in parallel like this, and the total charge is Q. How does charge get distributed? Let me call this capacitor as C1 and let me call this capacitor as C2. Charge on this capacitor is Q1 and charge on this capacitor is Q2. So you can see everything is similar. Resistance has been replaced by capacitance. This will be the positive plate and this will be the negative plate. This will be the positive plate and this will be the negative plate. Everything has been, everything is similar. Again, if you take these 2 points A and B, the potential difference across these points will be same. So you can write the same results. V, now remember V is Q by C. So Q1 by C1 will be equal to Q2 by C2 in this case. Somewhat different than register I1 R1. R1 was in the numerator. Here C1 goes in the denominator. And the total charge Q will be equal to Q1 plus Q2. Now, if I solve both these equations, this is the answer I am going to get. Q1 will be equal to Q into C1 upon C1 plus C2. I call it charge gets distributed in direct ratio of capacitance. The capacitor which has more charge, more capacitance will get more charge. The capacitor which has less capacitance will get less charge. And Q2 will be equal to Q into C2 upon C1 plus C2. So these are two very important results that you must remember. One is about the distribution of current. Current divides in inverse ratio of resistance, but charge divides in direct ratio of capacitance. I hope you understand this. Yes or no? Everyone understands this? I'll give you 2 minutes to note it down. Then let's move ahead and solve a question based on it so that we can remember this concept. Question number 4 or 5 or whatever it is. I have two parallel branches. Let us say I have a charge of 6 coulombs. This is a capacitance 2 microfarad. This is the capacitance 4 microfarad. Q1 charge comes on this one. This is plus, this is minus, this is plus, this is minus. Remember, Q1 is the charge here and Q2 is the charge here. Can you tell me the value of Q1 and Q2, the charge coming on each of the capacitors? I will give you 2 minutes to give me the answer for this one. Okay. So, how do you get this? If I have to find out the value of Q1, how will I get the value of Q1?
Q into C1 by C1 plus C2.
So, to get the value of Q1, I will multiply 6 by 2 and divide it by 2 plus 4. So the answer will be 2 coulombs. To get the value of Q2, this is 4 microfarad. What will I do? Q2 will be 6 into 4 upon 2 plus 4. So that will be 4 coulombs. Anyone understands this?
Yes.
So as you can see, the capacitor which has less charge is the capacitor which has less capacitance. The capacitor with less capacitance will have less charge. The capacitor with more capacitance will have more charge. Do we understand this, everyone?
Yes, sir.
No doubts on this one? Okay. So this was about capacitance and how does charge and current get divided here. Let us move ahead. And what is the next thing that we should do? Okay, let me get to that table. That table will not be able to do. So let me give you one more question here, and let's see if you can do this one. Question number 5. I have 16 amperes of current, and I have 3 branches, 2, 4, and 8 ohms. Can you now find out how much will be the current in each branch? I'll give you 2 minutes to do this. Well, I'll give you a formula to solve here. If I call this current as I1, if I call this current as I2, if I call this current as I3, now remember, your I1 will be equal to I into R2, R3 divided by R1, R2 plus R2, R3 plus R1, R3. So you have to take 2 each, multiply them together, and then divide. On this line, if you find out the value of I1, it will be equal to 16 into the other 2 branches. Other 2 branches are 4 and 8 divided by 2 into 4 plus 4 into 8 plus 2 into 8. Do we understand this? How I got this? You have to look for what I call symmetry. Now, on similar lines, can anyone tell me what will be the value of I2?
I into R1 into R3 by
Upon
R1.
so I will just write summation of R1, R2. Okay. What will be the value of I3?
I into R2 R1 by summation of R.
R1, R2. So this will become 16 into 2 into 8 divided by 2 into 4 plus 4 into 8 plus 2 into 8. Similarly, this will become 16 into 2 into 4 divided by 2 into 4 plus 4 into 8 plus 2 into 8. Do we all understand this, everyone? This formula?
Yes, sir.
This is division of current in three branches. This is the most difficult question that can ever come. Since we were doing division and we did not have enough time to do all the next thing, so I gave you this small concept of finding out the current in three different branches. Everyone got this? Yes or no?
Yes, sir.
So in today's class, what we have done is we have covered your series and parallel combination. In the next class, I will give you a table. You would have taken time to draw that table, and there was no point of giving you half of the table. So I'll give you a table where you have parallel, both of them together, and we can compare how things go in series and how things go in parallel branch. So we'll do them in the next class. In the meanwhile, I will request you to go through what we have done in today's class. If there's any doubt, please come up to me. Everyone has understood what we have done today? Yes or no?
Yes, sir.
Okay, then we'll meet in the next class. Take care and have a nice day. Bye bye.
Bye. Bye, sir.